Hi class, welcome back. So we're gonna move on to the next part of Matplot. So we're gonna do advanced Matplot. We don't use much of these concepts, but it's still good to review them. Most of the concepts that you're gonna be using is gonna be from Matplotlib. You're hardly gonna be, most of you won't, or most of us don't actually use advanced Matplotlibs, but there's some cool features that are worth talking about. So again, make sure that you click download the link and then into your computer, and then you go to your to your Colab. You're gonna click file, upload, find the notebook where you saved it, the file that you saved it, upload it, and then you're gonna be able to see this. Okay. All right. So let's start with this. And so the first thing that we want to do here is we can use different uh, different tools that allows you to methods that are specifically for Matplot that allows you to design or implement some values into your data. So for example, here we can take a normal scale values and transform it into a log values. So let me show you guys. So let's create the object first. We're gonna use. Oh, I think I'm missing something here. I think I need to, first of all, I need to import my uh, my PLT, my Matplot. So don't forget to do that first. So we're gonna do import matplotlib dot pyplot as PLT. Okay, so we're gonna import it first. Usually I like to have it in a different by itself. So let me just move this up and put it up here. And just to double check that I did it correctly. Um, okay, so now what we're gonna do is we're gonna use the PLT library to make sure that we're gonna create our object. So we're gonna use subplots, and we're gonna create two, right? So there's gonna be one row, two columns, and let's define the size. It's going to be 10 by 4. Oh, sorry, wrong. And I probably should write matplots correctly. Now what we're gonna do is we're gonna use our axis. I'm gonna grab the first one, and I'm gonna define the values for my data. So the x values would be x, and my y value would be x squared. And what I'm going to do here is I'm going to use the exponential function to define the values of my second graph. So this is my first graph, and this is my second graph. I'm going to assign a title to my first axis, my first graph. I don't like that they call it axis. They should call it something different. But whatever. Normal scale. It's very confusing when they use the words axis. So we're gonna do the same thing for the other one. So I'm gonna copy. We're gonna copy and we're gonna have x squared. And what we're gonna do here is we're gonna set the axis values. This is 1, 2. My white scale will be to the log values. So what I'm doing here is I'm actually setting specifically the values of my y to the log values. And let's see, let's call this log. And I don't think I have defined x yet. So I probably should define my x. And let's do x with, put it right here. I'm gonna import numpy. Well, actually, I'd rather put my numpy here. Import numpy as np. So we like to keep all of them in the same spot. And then my x will be equal to np dot line space uh 0 to 10, 11. I probably should maybe do 5 instead. Sorry, it's taking a while. All right, so let's run this. Module number has no attribute line space. What did I, line space? Lin space. Sorry, making mistakes. All right, and now we can see. Okay, good. So we can see, right, that even though they both represent the same graph, we decided to display the values of my y scale of my scale for my y values in the form of a log. So you can see, you can appreciate the graph a little bit better, right? So the only thing different is that instead of being from 0 to 140, is that now it's from 0 to 100. And it is in a form that it's going to be represented by the log. So because the log of the exponent function is just going to be x, that's why you see this straight line being represented as an orange one on the right side. And so that's the advantage of using it as a log scale. Okay, so let's move on to the next part. We can actually set the labels, the labels for the x values and the y values to a different text format using latex. So let's first create the object. plt.softplots fixed size is going to be equal to 10, 4. And then x.plot x comma x square x, that's for the first graph. The second graph would be x cube, and then the length of the length width, the length width would be equal to 2. And let's do ax dot set x ticks 1, 2, 3, 4, and 5. So that's how we're gonna separate the values. So that's the value separation. So that's gonna be like the alpha is 1, the beta is 2, the gamma is 3, the other one I don't know what it is, and the epsilon is 5. So that's the values that it's going to be representing, right? So that's the value, the actual numerical value, but we can actually assign a different label if we want to. So we can set the x ticks label and what we're going to do is we're going to use a bracket to represent the sequence, the list. And now what we're going to use is, instead of using an F string, we're going to use an R string. Now there's something different about an R string. And an R string, what it does, it removes any special annotation on any backslash. So any built-in format design with the strings, like for example, we know that backslash n represents a new line, or a backslash t represents a tab, or a backslash represents a backslash, or a backslash I think what else? Yeah, and many more, right? So, but if we want to remove, if we want to restrict any special format on the strings that is already built in, we can use an R string. So the R will remove any special symbol notation on any part of the string. So in other words, the backslash n does not mean anything. It just means that you're gonna have a string that has a backslash and an and on it. It's not gonna represent a new line. So we use that to make it a little bit easier when we actually input our special notation for backslash alpha, which is kind of like being able to do a latex format. So we want to be able to access this formation of beta and gamma and delta. So I'm just gonna copy this, guys. So this is beta, gamma, delta, and epsilon. And then we're going to do a font size equal to 18. So instead of having 1, 2, 3, 4, and 5, we're going to have an alpha, beta, gamma, delta, epsilon. And y ticks. We're going to do the same thing, 0. We're going to fix that to be 0, 50, 100, 150. And we can create a list and then just set it up like the way we did it before. I'm just going to copy this. And we're going to have, instead of the list, we can just put y ticks. And then for the labels, we're going to do special ones. Not going to do the R, but what we're going to, well, actually, let's do the F format, the F string format. So what we're going to do here is we're going to put in our value of our number. So let's call it y. So we're going to use y with 2 decimal spot, well, 1 decimal spot for the format. And we're gonna erase all the other parts. So we're gonna do a for loop here, and we're gonna do for y in y ticks. And so, and that's gonna be following using the format. Oh, actually, no, let me actually change it. I want to actually use the format of the latex. Let's see if this works. Labels. Okay, there you go. But didn't do, oh, that's supposed to be y. Let's do this again. All right. Okay, did it for one, but I forgot to put the valid symbol in the end. And there you go. All right. So as you can see, it gives us a nice format number using what we call a latex format. Latex format is a very scientific mathematical tool to create papers that usually are public. So if you ever do a thesis project, you gotta use a latex, or publish a paper. Most people use latex just because it's very convenient. So you can see that special symbol. If I wouldn't have used the latex, you would see that it would look a little bit different. So notice that if I remove those dollar symbols there, the 150, the 100 looks a little bit different. Taking a while. And you can see it doesn't have that nice format of the number. So let me put it back. All right, so we'll move on to the next one. So we can actually set it up so that our labels or our y values or x y ticks or x ticks, so your format of your numbers are in scientific notation. So let's create a object figure. And we're gonna use ax.plot dot x square x cube. Oh, sorry, exponential. Let's do x cubed as well. And we're gonna set the notation ax set title scientific notation ax dot set y ticks. It's always better if you actually write it by the suggestion that they give you. Otherwise, most of the time, as you can see, you can make mistakes. So I'm gonna use 0, 50, 100, 150 as my y values, but I'm going to I'm gonna, from the Matplotlib, I'm going to import a ticker, and I'm gonna use it to format my y value. So I'm gonna use my ticker to scalar formatter, use math text, use math text equal to true. So we're gonna set it up as a math value. Import ticker. So what we're gonna do here is we're gonna format the y value range. We're gonna say our formatter dot set scientific true, and then formatter dot set power limits -1, 1. So that's your exponent power limits, and your y value major formatter will be defined by our formatter. Okay, so let's see what we did. We want to display these values in our y-axis, but we want to modify them so they look like a scientific notation format. So we need to export this ticker from the Matplotlib, and we're going to use this ticker that has this object, or this class scalar formatter, that is going to use a math text format. This is scientific notation, is a math text format. So we're going to set our formatter to be a scientific notation. We want to define or limit our powers to be between -1 and 1. And then we want to assign our AX to be for our y-axis to be set to our major formatter, which is a formatter. And let's see if that works. Okay, good. And then we can always hide them. We can always hide our work. It's a clear output, but right here. We can always hide it if we want to. If sometimes data becomes too long, we can always format it. All right, so now what we're gonna do here is the next ones, they don't do much. I'm not gonna skip those. Axis position adjustment also. We're gonna go into the grid. This is good because this is actually useful. So we're gonna jump into the grid. We're gonna create our axis equal to plt dot subplots big size 10,3, and axis 0. We're gonna assign the first axis plot values to be x comma x squared comma x cubed, and then the line width would be 2. Also notice that we were able to graph more than 3, more than 2, so we can keep adding more graph if we want to, just by add in a comma, x value, and then the y value. This has if you look at the plot, it has a asterisk and args. So that means that you can put as many arguments as you want. Let's go down here. And so this is our first one. And then axis grid true. So we're gonna add our grid. We're gonna make the grid visible, and then we're gonna customize our grid on this one. So I'm gonna use the same thing. I'm gonna change this to 1, and then color equals to B, blue. So we're gonna change the grid to blue. We're gonna make it a little bit transparent by doing an alpha equal to 0.5. And then we're gonna have the line style to be equal to dash. Line width equal to 0.5. And there you go. So it helps us because you can actually see where the values are specifically. And so that makes it a little bit easier, right? Okay. Let's see if we add marker. And then you can see a little more points on the graph. Remember that we set up those values from the beginning. We asked for 10 values, practically 10 values or 11 values from 0 to 5. So those are the 11 values that we're looking at right now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So those are the points that we can visualize the values of the data. And so yeah. Right, so it's good to see the grid because then you can actually see where each one, where is located each value of your data a little bit more exact. Let's do the next one. So fig dot x, again, is to create the object. We're gonna have an empty one right now, plots fig size equal to 6,2. Ax dot spines set color blue. Ax dot spines top dot set. Oops. Set color blue. And I'll explain right now what this means. I'm going to repeat this process with the left side. And we're going to set the color red. And this is going to be setting up the length line width. Okay. So let me explain what this is doing. So we're creating the object first of size 6x2. And what we're going to do here is we're looking at the outer layers of your graph. And we're saying that the bottom one, we want to make it color blue. So we want to color blue the bottom part of your graph, the bottom line. And then the top one, we want to make it blue as well. So that's the top line. And then the left one, we're going to make it color red. And then on the right one, we didn't give them a color, so it's not gonna be. We're gonna remove it actually. We're gonna remove the one on the right. So right now, if I run it, there's gonna be a line, but I want to make my line a little bit more thicker on the left side. I'm going to remove the right line of my graph. So I'm gonna do AX spines right, set the color to none. So we're gonna make it empty. Okay, and then what we're gonna do is y-axis dot tick underscore left. What we're gonna do here is, oops, what is this highlighted? So we're only gonna be able to see the ticks on the left side, not on the right side. Okay, so the ticks are your values 1, 0.0, 0.8, 0.6, 0.4, 0.2, 0.0. So let's run this. And as you can see, the right side doesn't appear. But I can, if I put here red, then you're gonna be able to see that we can see the right side line. But I'm gonna put it as none, so we don't want to see it. And that's it. And then now we can actually take it to another level and actually, let's say we do want to see it, right? So what we can do is something called the tween axis. And so let's copy some of this stuff that we have here. Just gonna copy this. And it's gonna be the size. I'm not gonna go specifically for a size. Just whatever they give us. And let's call this axle x1. X1 plot x square, line width will be 2, color would be blue. X1 dot set y label. No, not y ticks, y label. And we're going to do the same thing that we did before. We're going to use the R, which removes any special notation on any string. So we're going to use this M, this stellar symbol, to represent it in latex format. Font size equals 18 and color equals blue. So that's one of them. And the advantage of using this dollar symbol is because we're going to be using the format of latex. If you use this caret symbol, it's going to make it into a square. So that's going to help us visualize it better. X1 dot get underscore y ticket label, and we're going to assign it a color to our ticket value. So our ticket, so remember our ticks labels are gonna be the 0, the 5, the 10, 15, 20, and 25. So what we're doing here is we're setting up the color for every single tick label. So that's what we're doing. We're gonna use the method get y ticks label. So that's to access the y tick labels. So we're gonna put them here as a list. We're gonna grab them and we're gonna set them each with a color blue. So we need to use the get, not the set, the get. Okay. And then we're gonna do the same thing for the AX2. But before we do that, we're gonna mimic what we have. Sorry, we need to add another feature to our AX1. So we want to add a feature to our AX1, which is gonna be our twin X. AX2 plot X cubed. Actually, I'm gonna write. I'm just gonna copy this what we have here. I don't wanna redo everything. That's 2. That's 2. That's 3. That's 3. I'm gonna make this color red. This is gonna be a cube. And this is gonna be red and red. And this is AX2. And there you go. So what allows us to be able to represent the Y ticks on the right side with different values is having this twins. This twins allows us to add a different label on the right side of our figure. But everything else, as you can see, stayed the same. We didn't do anything different. It's just allows us to mirror the labels to the other side. Now notice that this has a now special m cube and m square, and that is because of the latex format. But you have to make sure that you use the R string. Okay. All right. So let's do. Let's do this XY plane. So again, we're gonna do the same thing that we did before. Big comma AX equals PLT dot stop plots and AX dot spines right. So remember, we're gonna remove. Our goal is to remove some of the spines from the left and the right, from the right side. So I'm gonna do set color to none. So what we're doing is removing the right line of my figure. I'm gonna do it again with my top. So I'm gonna use top, and I'm gonna remove it as well. And so now that I removed 2 lines, so now I have I removed 2 out of the 4. Now what I want to do is I want to move the left line to the middle and the bottom line a little bit higher. So what I'm going to do here is I'm going to say AX dot X axis dot set ticks and position bottom AX dot so what I'm doing here is I'm setting my the ticks of my position on my x-axis. Okay, so on my bottom, and then I'm gonna do spines bottom. So I'm gonna move my bottom dot set underscore position. Oops. My data. Sorry, data and quotations and 0. So what I'm doing is I'm saying, hey, I want to have my position of my data of my x-axis to be placed on the position 0 of my y-axis. So that's what we're doing. We're moving it up. That's what we're doing. We shift it up. And we're going to do the same thing for the left one. Okay, so again, here we're setting up, we're saying, hey, my x-axis will be in the same position of my bottom. And now what we're going to do here is I want to set my y-axis in the same position as my center. Okay. And now what we're going to do is we're going to set our values to be between negative 0.75. So it's going to start at negative 0.75 to 1. And we want to have 100 values from there, between there. 100 values. And we're going to use that to plot those values in our graph. So this is just setting up our XY plane, but this is allowing us to get the information, the data that we want to plot. So we're going to go from 0.75, negative 0.75 to 1, and we're going to grab 100 different numbers between them, and we're going to use them to plot them into our graph. So, and there you go. So as you can see, it starts at negative 0.75 and it goes all the way to 1. And you can see that it's being shifted up so they can take the position of the center of the origin. Okay. Otherwise, it will look something like this. So you can see that your bottom line and your left line are not in the center. They're not in the middle. So this is what this is doing, right? So if I put this guy back in, this is going to shift my bottom line a little bit higher where the origin, where the y-axis is equal to 0, where the y is equal to 0. And if I do the same thing here, then I'm gonna be able to move my value so that my y-axis is in the middle of where my x equals 0. Okay. And then so now I can show you guys different types of graphs. Let's actually create some data. So n equals np.array, and my data would be just the numbers 0, 1, 2, 3, 4, and 5. Again, I could have done it just by doing the word range from 0 to 5. Sorry, to 6. So I could have done the same thing, and it would have given me the same values. Okay, I'm gonna do my figure. My axis is going to be plt.subplots 1,4 fig size equal to 12,3. And so what I'm going to do here is I'm going to create some random graphs. So I'm going to use axis, and this is my first graph. So we're going to have 4 different graphs. So this is my first one, 0. Sorry, dot plot, scatter. We're going to do a scatter instead of a plot. And we're going to have our axis, comma, x plus 0.25 times my random rand normal distribution of my length xx. And we're going to use axis 0 dot set the title to, I'm going to call it scatter. So that's the first one. I'm gonna do the same thing for the next one. So I'm just gonna copy this, change this to 1, and my values would be just, I'm just gonna keep this to my square. So it will be n, comma, n square, comma, length width would be equal to 2. And then we're going to call this step. So we'll use the, that's going to generate a step. Now I have to change it to, instead of a scatter, it's going to be a step function, a step graph. So make sure you change it to step. I'm going to use this one to make my bar. So that's going to be 2, 2, and this is going to be bar. And we're going to use align to center equal to 0.5, and a little bit transparent, alpha equals to 0.5. And then we're gonna call this bar. And then we're gonna do, and one more, to the field. And let's do x, and then x squared, and then x and x cubed. And we're gonna color with green. And we're gonna make it a little bit transparent. So what we're doing here, this is going to be fill between the graphs. So what this is gonna do is gonna do 2 graphs, and what we're gonna do is we're gonna color between the 2 graphs with the color green. And there's something wrong here. Okay, so I fixed it. For some reason, it didn't like the fact that I used a range to create the array. For some reason, I don't know why. It should give me the same thing. But you can see now that we have the 4 graphs, right? This is the scatter graph with random representation of numbers distributed. And then we have the step with the step graph. We have the bar. This is the width of every single bar, center, this transparency. And then we have the fill in between those 2 graphs. All right. And okay, just a few more. I don't want to make it that long. We're at 49 already. All right, so let's keep going. I think this one's still beneficial. So let's do text notation. Big comma ax equals to plt dot subplots, and then ax dot plot. Again, we're gonna assign the value x, and xx will be square, and xx and xx cube. Ax dot x, we're gonna be able to put in the value, assign a location and a value to the graph, so like a label on the graph. Instead of like a legend, we can actually assign a label. So we're gonna do 0.2, and my label would be r y equals x square. So again, remember, I'm using this r because it's gonna remove any special format on the string format. We're gonna put a font size of 20, and color is going to be blue. And then the other one, we're gonna put a 65, 3, 20, and green. So what this is doing is putting this y equals x squared, this y equals x cubed label on the graph. This is the location where we're gonna put it. So it's going to be located at 0.15 on your x-axis, and then 0.2 on your y-axis. You can see that the y cube is located at 0.65 of your x-axis, and at 0.1 of your y-axis. Okay, so you can see that it's mapped right there. It's like the coordinates. These are the coordinates where you're gonna place your label on the graph based on the x values and y values that you have. All right, so we can do multiple plots and so in order to be able to do multiple plots, we can do we did it with just using the Matplots, the subplot, sorry, plt.subplots 2, 3. That gives you 2 rows and 3 columns. Fig.height layout, and so that's just to give you 6 empty values. But if let's say we want to modify them, like we want to place them in a specific location, well, we can do that by doing our fig plt.figure. So this is creating the object, and then what we're gonna do is we're gonna create we're gonna create 5 different axes. plt.subplot to grid. So we're gonna use a grid to be able to specify where we're gonna put them. It's gonna be a 3 by 3, comma, and this is going to be located at 0, 0. So that's gonna be the first one. And then the next value that we're gonna put is going to be how do we wanna span, or how long do we want this figure to extend. So we want it to extend through the 3 columns. So that's the first one. The second one would be we want to place it on row 1, column 0, and this is going to extend over 2 columns. The next one would be 3 located at 1, 2. And this is going to extend over 2 columns. So actually row span. This is row span. So this is located, the axis 3, this is the one in the all the way to the right, is going to be starting at row 1, column 2, and is going to span downwards to two rows. And then we have number 4 and 2. It's going to be located at row 2, column 0, and it's not going to expand. Doesn't have any place to expand. And then the last one, and there you go. So we able to expand all our different values, right? So let's say we didn't want to have them all in the same shape. We can actually extend the shapes by using the subplot to grid. Okay. We can do this a little bit easier if we actually use the grid specification. So we would have to import the Matplotlib grid spec as grid spec big equals plt dot figure, and we're gonna create this grid spec, right? So this is just creating the object. Now we're gonna create this specification of our grid with the grid spec dot grid spec, and we're gonna make 2 rows, 3 columns. The height will be for the for each one, right? It's gonna be for the first one, the height will be 2 rows. For the second one will be 1. So this is talking about the rows, right? So it's talking about the row, each rows. For the first row, the height will be 2. For the second row, the height will be 1. And now we can do the columns. For the columns width ratios would be 1 to 1. So this is ratios. Matplot. And then this. So remember, whoops, ratios. And then we want to visualize them. Big height layout. Oh, I think I forgot to for G in GS, I forgot to create an axle for each one. We're gonna create a axle, that's your canvas for each of them. We're gonna add a subplot of G. So we created those objects, the grids, and we're gonna use them to create our our graph. So again, remember we're gonna have 2 rows, 3 columns of graphs. The height ratios for the rows would be 2 and 1. The width ratios for the columns will be 1, 2, and 1. Now, this is just creating a list of grid specifications, not creating the figures. So we need to create the figures using the axe, right? Remember, we need to create those axes. So we're gonna go for AVG and GS. We're gonna create another subplot of G. So we're gonna grab each of the G's and we're gonna add it to our axle, and then we're gonna display it. Now, there you go. So that's if we have a bunch of them that look the same. Okay, I think this is the last one that we're gonna talk about. Okay, so let's say we have a fig. We want to create our fig, and we want to zoom in to a specific location. Again, there is. Oops, sorry. Seaborn has a lot better features than Matplot, but it is good to understand this one first before we can talk about the Seaborn. And so again, we're creating our axle. We're gonna have a big layout, tight layout. And we're going to add this interior, right? This inside axle. We're gonna call it inset ax, or inner set ax, fig. We're gonna add the axis, right? The location where we're gonna put it. Zero 0.2, 0.5, 0.35, 0.35. Okay, so this is gonna be the location where we're gonna put it, and then we're gonna have our inner set ax plot. We're gonna give them the values that we want: x squared, x cubed, and inset underscore ax dot set underscore title zoom near origin. So this is just to kind of display a little bit of the zoom part of it, a little more specific. And then let's do the location, right? The range, actually. The inset ax dot set x limit negative 0.2 comma 0.2 inset ax dot set y limit, and that's going to be negative 0.005 0.01, and then we're gonna set the axis location. So we're gonna set inset ax dot set y ticks. So this is the ticks that we want to be able to see inside